Hey YouTube, tonight I wanted to do a short video at the request of a student. I'm going to do a video on finding lines that are parallel and perpendicular to a graph. And so I just logged on to Googled the subject, found a couple example problems. We're just going to do a couple together, and then hopefully if you have any questions you can message me those. So if you can see the green text, that's the one we're going to start with. Okay, it's always good to teach something with a problem to give you a little bit of context. So let's write this down on a piece of paper. Okay, so our equation is 2x minus 3y equals 9. Okay, so 2x minus 3y is equal to 9. And they want us to find lines through the points 4, -1, that are parallel and perpendicular to the original line. Okay. So just to recap, here's what they want us to do. This is our original equation. Okay. They want us to find both parallel and perpendicular line equations that also pass through the point 4, -1. Okay? It's always a good idea to know exactly what they're asking you for before you start any problem. Okay, so in order to understand what we're going to be doing tonight, you need to have a solid understanding of line graphs and slope-intercept form. So if you don't know that stuff already, please go review it and then come back and watch this. Okay, so I'm just gonna go through this. So here's the equation they gave us: 2x minus 3y is equal to 9, and they want to pass through the point 4, -1. I'm going to divide this problem up into a couple steps. 3 steps actually. Step 1, for any problem like this, whether it's parallel or perpendicular, find the parallel / perpendicular slope. Okay. So let's go through both of these cases. For parallel lines, they have the same slope as the original equation. And for perpendicular lines, the slope of the perpendicular line is going to be the negative reciprocal of the original equation's slope. Okay, so that's step 1. Let's go ahead and do step 1 for these cases. So if I've got this equation, 2x minus 3y equals 9, and let's say I want to find the parallel slope first. Well, first I need to get this into slope-intercept form, which is of this format: y equals mx plus b. So in order to figure out what the slope is, I need to get this y totally by itself. And we're going to do that using some algebra. So let's go ahead and move everything off to the side using order of operations so that we can get y by itself. Okay. I'm going to bring this -3 over, leaving our y totally alone. So y is equal to 9 over -3 minus 2 over -3x. And just because I like it in the y equals mx plus b format, I'm going to take my x and move it to the front. So y is really equal to negative, or actually we have 2 negatives right here. That's going to make it a positive. So y equals 2/3 x minus, well, 9/3 is just the same thing as 1/3. So there is our equation in slope-intercept form. So now we can find our slopes for parallel perpendicular lines. Let's start with parallel. So m is the variable we usually use for slope. So the slope of the parallel line, if you read our hint up above, parallel lines have the same slope as the original equation. So if our original equation slope was 2/3, the slope of the parallel line will also be 2/3. Bingo, boom, done. If we want to find the perpendicular slope, we take the negative reciprocal of the original equation's slope. So if our original equation's slope was 2/3, we're going to negate that and then flip it. Taking the reciprocal is the same thing as flipping it. So whereas before we had positive 2/3, our perpendicular slope will be negative 3/2. Okay, that's step one. Let's go on to step two. So step two, we need to figure out b. Okay, so remember how y equals mx plus b? Well, we just figured out what m is in our parallel and perpendicular equations. The only other missing piece of the puzzle is what b is in each of those equations. Now we can figure out what b is using the given coordinate that these lines are going to pass through. So if you go up to the original question, it says, find parallel and perpendicular line equations that also pass through the coordinate 4, -1. Okay? So if I'm working with the point 4, -1, let's go ahead and see if we can figure out what b for the parallel line is. Okay? So we're going to take the coordinate they want the line to pass through and basically substitute those numbers in for the variables they correspond to. Okay? I'm going to substitute my 4 in for my x, my -1 in for y. My m is not going to change. So y is equal to, actually we're substituting our -1 in. -1 is equal to our m, which was 2/3, times our x, which is now 4 from our substitution, plus b, which we don't know yet. But now we can simplify and get b by itself and complete this this step. So I'm going to do that. -1 is equal to 2/3 times 4 plus b. 2/3 times 4 is just 8/3. So -1 is equal to 8/3 plus b. Get b by itself. Let's go ahead and move this over. Always make sure that you are moving things around algebraically using order of operations. So b is equal to -1 minus 8/3. And we can go ahead and use a common denominator to figure out what that simplified is. Okay, so -3/3 minus 8/3, that gets me -11/3. And that's what b is. So going back up here, the b for my parallel line is -11/3. Let's do perpendicular now. So b perpendicular is equal to something which we're going to figure out. So same thing. We're just going to figure out what our b is by substituting our point in. Remember, our point is 4, -1. We're going to use y equals mx plus b. Except for this one, our slope for our perpendicular line was -3/2. So once again, this is going to go in for y. This is going to go in for x. So -1 is equal to -3/2 times our x, which is 4, plus b. Let's go ahead and get b by itself using order of operations. So -3/2 times 4 is going to be -12/2. Okay, we can get that out of the way. And actually, I'm going to make this easier on myself. -12/2 is the same thing as whatever negative 12 divided by 2 is, which would be negative 6. So negative 1 is equal to negative 6 plus b. Let's get that 6 out of the way, get b by itself. Negative 1 plus 6 is 5. Okay? So b for our perpendicular line is 5. Okay, step 3, final step. Substitute m and b into slope-intercept form for both parallel and perpendicular cases. So this is the step where we put everything together. So remember, y equals mx plus b is what we're looking for in the equation. For our parallel case, our slope was 2/3, and our b was negative 11/3. Okay, and so we can go ahead and start a new slope-intercept form, plugging that information in. So y equals 2/3 x minus 11/3. And there's our equation for our parallel line. Going over to our perpendicular case. Well, our m was negative 3/2. Our b was 5. Thus, y is equal to negative 3/2 x plus 5. And we are done. Okay, I hope that's helpful to you as you study this concept. Really, when it all comes down to it, it boils down to 3 basic steps. Once again, find the slope using the parallel or perpendicular relationship. Use the slope and the given point to solve for b is step 2. And then step 3, plug in m and b into a slope-intercept equation. So without further ado, I guess we'll call it a night. Thanks so much for